The bend radius is the radius of curvature of the bend. This we have two types of stresses in this bent portion, tensile stresses on the outer portion and the compressive stresses on the inner side of the bend. This tension or compression is directly proportional is inversely proportional to the radius of curvature of the bend. Due to this tension and compression, this neutral axis, which is generally in the center of the length, center of the thickness, then due to this tension or compression, this neutral axis moves toward the inner side of the bend, and the distance of this neutral axis from the inner side of the bend is generally 0.3 t to 0.5 t. Then comes bending methods. Two bending methods commonly used are V bending and edge bending. In V bending, a wedge shaped punch forces the metal sheet or strip into a wedge shaped die cavity. The bend angle may be acute 90° or obtuse. So, it is very simple process in which a wedge shaped punch forces the strip or sheet into a wedge shaped die, and the angle formed may be acute 90° or obtuse. Acute is that angle which is less than 90°, and obtuse is that angle which is more than 90°. So, we can have any type of angle. Then comes edge bending. In edge bending, a flat punch forces the stock against the vertical face of the die. The bend axis is parallel to the edge of the die, and the stock is subjected to cantilever loading. So, this edge bending is very simple press working operation in which a straight length is held with the help of some pressure pad, and a straight punch forces the cantilever downward, and this type of loading is called cantilever loading. Then comes principle of metal cutting. What actually happens inside the metal when the cutting operation is performed, that is explained in principle of metal cutting. The cutting of sheet metal in press work is a shearing process. The cutting action is explained with the help of figure. The punch is of same shape as of the die opening, except that it is smaller on each side by an amount known as clearance. As the punch touches the material and it travels downward, it pushes the material into the die opening. The material is subjected to both tensile and compressive stresses as shown in the figure. Stresses will be highest at the edges of the punch and die, and the material will start cracking there. The various steps in the rupture or fracture of material can be written as stressing the material beyond its elastic limit, then plastic deformation, reduction in area, fracturing start in the reduced area and becomes complete. Now, I explain you what actually is happening during a cutting operation. First of all, we have a straight strip or workpiece, and this punch is coming down. When it contacts, it pushes the sheet or strip into the die. Now, two type of stresses are produced in this work material, these are of, on the outer side these are of tensile nature, and on the inner side these are of compressive in nature. Maximum tension or compression takes at the edges. So, due to this tension or compression, this area gets reduced and the fracturing start on the cutting edges of the punch on this as well on this side. Similarly, cutting edge of the die on this side and cutting edge of the die on this side. So, fractures start one from this side and second from this side, one from this side and second from this side. If the clearance between the punch and die is correct, then fracture starting from the die meets the fracture starting from the punch. If these cracks meets one another, then fracture is complete. So, clearance is very important in this cutting operation. Clearance is nothing but a difference in the sizes of size of punch and the size of the die. If clearance between the punch and the die is correct, the cracks starting from the punch and the die edges will meet and the rupture is complete. If the clearance is, suppose clearance is too large, then crack starting at the edge of the die may go like this, and the crack starting at the cutting edge of the punch may go like this. These two cracks do not meet. Similarly, cracks starting from the bottom of the punch may not meet a crack which starts from the cutting edge. So, it goes like this and this crack goes like this. These cracks do not meet. So, in this case fracture is not completed. Similarly, if the clearance is too small, mean a fracture starting at the this edge of the punch may not meet with the fracture starting from the cutting edge. So, again there will be no rupture of fracture, only metal will be ragged. So, in this case clearance is very important. It should be correct. Then comes for cutting operations, the position of the punch and position of the die should be very correct, mean the alignment of punch and die should be correct. When the shape of the blank to be cut is irregular, the summation of shear forces about the center line of press ram may not be symmetrical. Due to this, bending moments will be introduced in the press ram, producing misalignment and undesirable deflection. To avoid this, center of pressure of the shearing action of the die must be found out, and while laying out the punch position on the punch holder, it should be ensured that center line of press ram passes exactly through the center of pressure of the blank. This center of pressure is the centroid of the line perimeter of the blank. It should be noted that it is not the centroid of the area of the blank. Now, if the workpiece is not symmetrical, then shearing forces on one side of the center line of the ram may not be symmetrical to the sum of the shearing forces on the second side of the center line of the press ram. Then due to this bending moment will get introduced. and due to that deflection will be there and cutting will not be proper. So, what we do, we have to find out the center of pressure of the workpiece, and the center line of press ram is made to pass through the center of pressure of this workpiece. Now, a figure is shown on your monitor. It is a workpiece which is not symmetrical in shape. Now, we have to find out its center of pressure. What we do, first of all, we lay out a workpiece, then then this workpiece is divided into line segments like first segment, second segment, third, fourth, fifth, sixth, seventh and eighth. Then the length of the line segments is calculated. It is taken as L1, L2, L3, L4, L5, L6, L7, L8, and similarly then centroid of these line segment is calculated. Centroid mean center point of this line is calculated. Similarly, centroid of this line means center of this line. Then distance of the centroid from the x axis and y axis is calculated. Suppose L1 is the distance of the first line segment from the y axis, and similarly y2, y1 is the distance of this line perimeter, centroid of the line perimeter from the x axis. Then centroid is calculated as x distance is calculated as L1 multiplied by x1 plus L2 multiplied by x2 plus L3 multiplied by x3 and so on, and this is divided by sum of the distances of the centroids L1 plus L2 plus L3 plus and so on. Similarly, y component is calculated by L1 multiplied by y1 plus L2 multiplied by y2 plus L3 multiplied by L3 and so on. Similarly, it is divided by the summation of the lengths of the centroid from the x axis L1 plus L2 plus L3. Then we get two coordinates, one is x coordinate and second is y coordinate. These are the distance of the center of pressure from the x axis and y axis. And before starting the cutting operation and before laying the punch on the, before positioning the punch on the ram, the center line of the press ram is made to pass this center of pressure we have just calculated. Then and only then we can have a proper cutting operation. Thank you very much.